Hello students, this video is for the Unit 2 Lesson 1 on special triangles. We're going to be talking about the different types of vocabulary words that you'll see associated with triangles, how to identify a type of triangle, and then once you know what type of triangle it is, how to use that piece of information to help solve problems regarding those triangles. The first thing I want to look at is the learning target. Today we're going to be applying triangle theorems, ideas about triangles or concepts that we believe about triangles in order to identify relationships within the rectangles. For example, if I know something about a piece of a triangle, I'll be able to figure something out about the other piece of a triangle. And we're also going to try to determine unknown angles in diagrams. We're actually going to go a little bit further than just unknown angles. We'll also be looking at unknown sides. The first thing I want to talk about is the definitions for scalene, isosceles, and equilateral. These are actually words from ancient Latin and Greek, respectively. They refer to different types of triangles. You should have seen these already in previous math classes, but here's a refresher just in case you forgot. And like I said, these first two names are from the ancient Greek for uneven and for same legs. Uneven scalene triangles have 3 different side lengths. You can see that there's 1 hash mark here, 2 hash marks here, and 3 hash marks here. That doesn't mean 1, 2, and 3 inches, respectively. It just means everything with 1 hash mark within one diagram is the same as 1 hash mark in any other place. If it's got 2 hash marks in this one diagram, it's going to be the same as any other side with 2 hash marks. But you can see that there's 2 hash marks here, 1 and 3. Nothing is the same in this particular diagram. Same thing here, same thing here. They are all different. For isosceles triangles, there's going to be 2 sides that have the same length. We call those 2 sides congruent sides because congruent means equal measures. 1, 2 with equal measures, 1, 2 with equal measures. And what we can do from that is say, well, if I know that 2 sides have equal measures, I know that 2 angles have equal measures as well. It's going to be angles that are across from the sides. They're called base angles, and you can always identify where the base angles are based on where the congruent sides are. For example, if I'm looking at this pair of congruent sides, use another color, this pair of congruent sides, this one and this one, across the triangle from that and across the triangle from that are the 2 congruent angles, the 2 base angles. Very easy to figure out just by going across the triangle from the sides to the angles. Then last but not least, we're talking about equilateral triangles. Equilateral is Latin for same sides. Sometimes they call that equiangular. This is a little bit more rare that you would see the word equiangular. Equiangular just means equal angles, as you could probably guess. And all 3 angles have the same degree measure, which is always going to be 60 degrees. That's a true fact about triangles, and we're going to allude to this fact in our next lesson when we talk about the sum of all the angles inside of a triangle. But anyway, an equilateral triangle has all equal sides, and you can see that with the 1, 2, 3 hash marks that are all 1 hash mark. Perfect. Moving on to the names of triangles that are based on their angles. These are acute, obtuse, and right triangles. Again, you might have seen these in math classes past, but just in case you don't remember, here's a quick refresher. This first type of triangle is an acute triangle. When you think of the word acute, you should think of acute, like small things are cute. So that means all 3 angles are acute. They're small angles, and by small I mean between 0 and 90 degrees. All of these angles you can see are below 90 degrees. They obviously have to be higher than 0 degrees, or else they're no longer angles, they're just lines. One angle is an obtuse angle. As soon as we can prove that about a triangle, we can say it's an obtuse triangle. We can see here that it's an obtuse triangle because there's one angle that is larger than 90 degrees, but less than 180 degrees. Similarly here, larger than 90 degrees, and larger than 90 degrees. The other angles are going to be acute in the triangle, and the reason for that will be revealed a little bit later when we talk about the sum of the angles in a triangle, but for right now, all you need to do is prove that one angle is obtuse in order for the whole triangle to be obtuse. And right angles, you should be eminently familiar with these. Right triangles have 1 right angle in them. You can tell by this telltale boxy shape there. That tells us that this angle is 90 degrees. Again, the same with obtuse triangles. There's going to be 2 angles that are acute angles in this triangle, but one of them being a right angle is enough to prove that it is a right triangle. The only way to prove that a triangle is an acute triangle is to say that all 3 of its angles are going to be acute. We can't just say that 2 angles are acute and that's enough, because in this triangle there's 1, 2 acute angles, but there is 1 obtuse angle as well. All right, moving forward. Now we're approaching the isosceles triangle theorem, which is a concept that tells us that the relationship between sides and angles is it goes both ways. And here's what I mean by that. I mean that if a triangle has two congruent sides, if I can prove that its two sides are congruent, then its two base angles, and remember we talked about base angles being the ones that are across from the congruent sides, its two base angles are going to be congruent as well. And vice versa. This vice versa is a phrase that means and the same way the other way around. So, in other words, if a triangle has two congruent base angles, then we can go across the triangle again and say that means its two sides are congruent. So if I know that two angles are congruent, the sides are congruent. If I know that two sides are congruent, the angles are congruent. It goes both ways. It can be proved both ways. That's what we mean by this vice versa. All right, moving on to some model problems. Let's take a look at what this actually looks like in a mathematical setting. All right, looking at that first model problem, we can tell that it's giving us some information here, and just like any other problem, we're going to annotate it. XZ is equal to 10 centimeters, which is labeled here. YZ is equal to 4 centimeters, which is labeled here. And it tells us the measures of these two angles. M angle XYZ means the measure of angle XYZ is 42. We don't put a degree marker because the M indicates the measure in degrees of angle XYZ is 42. What other information can be determined? Well, I know that this angle is congruent to this angle. It's given to us already that those two angles are the same measurement. If I know that those are the same measurement, they have two congruent base angles, then we can use the Isosceles triangle theorem to say, well, if a triangle has two base angles that are congruent, then its two sides are congruent. How do I tell which sides they are? I just go across the triangle from here to here, and then from here to here. That means XZ is 10 centimeters, which also means that XY must be 10 centimeters. And we're able to write out the reasoning for this by simply saying that we're using the Isosceles triangle theorem. In this case, just saying if two base angles are congruent, which we know to be the case, then the two legs are congruent, which means XZ and XY are the same. So I can write out the other information that I can determine about the sides and angles of XYZ. Well, the piece of information that I was just able to obtain is that the XY is equal to 10 centimeters. So I finish off the problem by saying XY is equal to 10 centimeters. Boom, done. Next, I'm given the fact that this is an isosceles triangle and its legs are represented by 2x minus 9 and x plus 5. I have these two legs and I know that I'm looking for the value of x. That's what it's asking me for. It gives us 2x minus 9 and it gives us x plus 5. So what I need to do is figure out what the relationship is between these two sides. Well, I'm told it's an isosceles triangle. And luckily for me, I remember that isosceles triangle means that the two legs, the two sides, are going to be congruent. This is a fact that I could use to prove my statement. If you'll notice, I'm using this picture of a triangle as a little bit of shorthand. Sometimes geometry teachers will do that. They'll use this symbol for triangle instead of writing out the word triangle. You are totally allowed to do that on the geometry regions. It will save you about 1 second. All right, so now that I know that these are congruent legs, all I'm going to say is these two sides, these two legs, are congruent to each other. Or in other words, their measurements are equal. So here's how that looks. And now I'm able to set up my equation. I know that both sides are going to be equal to each other. Now all I have to do is, as it asks me here, find the value of x. And with a little algebraic manipulation, I can find out that x is equal to 14. Not so bad. So what we've done today for this lesson is we've identified different types of special triangles, and then we've used those special triangles, we've used the relationships within to try to answer questions. Now normally I would end the video here, but I want to give you a little sneak peek into what the problem set looks like. In this problem set, I'm asking you to identify the types of triangles by their sides and by their angles. For example, this triangle has 3 differently sized angles, which means it's scalene. And it also has all 3 angles that are less than 90 degrees. 80, 60, and 40 are all acute angles. So I can identify this triangle as an acute scalene triangle. Very easy to do. You can just label them into these boxes. All right, that was the video on special triangles. Good luck studying.